There's something humbling about looking up at the night sky, realizing that every star, every distant speck of light, is part of a story far grander than we can fully grasp. But what if I told you some of those celestial objects aren't just mysterious, they're downright impossible? Structures so vast, so bizarre, they shouldn't exist according to everything we know about the universe. And yet, there they are, defying explanation, rewriting the rules of physics, and forcing scientists to question the very fabric of reality. Today, we're diving deep into the cosmos to uncover 25 of these mind-bending anomalies, each one a cosmic puzzle waiting to be solved. Picture this, a megastructure so enormous it could dwarf entire galaxies, or a cosmic formation that radiates energy in patterns we can't begin to decipher. These aren't science fiction, they're real, they're out there, and they're changing the way we understand the universe. Some of these enigmas might hold the key to the origins of existence itself, while others could reveal secrets about how the cosmos will end. And the most thrilling part, astronomers are still discovering new ones, each more baffling than the last. This isn't just a tour of strange space objects, it's a journey into the unknown, where every discovery raises more questions than answers. What do these structures mean for the future of astronomy? Could they hint at forces or dimensions we've yet to imagine? By the end of this exploration, you'll see the night sky differently, not just as a canvas of stars, but as a living, evolving mystery filled with wonders we're only beginning to uncover. So let's set aside what we think we know and step into the extraordinary. The universe is ready to surprise us. The first stop on our journey through cosmic mysteries takes us to one of the most unsettling gravitational puzzles in the universe, the Great Attractor. Imagine an invisible hand in deep space, so powerful it's dragging hundreds of thousands of galaxies, including our own Milky Way, toward it at millions of miles per hour. This isn't science fiction, it's real, and it's happening right now. But here's where things get strange. We can't actually see what's pulling us. The Great Attractor lurks in what astronomers call the zone of avoidance, an area obscured by thick dust and stars from our galaxy's disk, making it nearly impossible to observe directly. What makes this even more mind-bending is the sheer scale of its influence. The Great Attractor's gravitational pull stretches across hundreds of millions of light-years, warping the motion of entire galaxy clusters like a cosmic puppet master. Some theories suggest it could be an unimaginably massive supercluster, a dense knot of galaxies bound together by gravity. Others propose something far more exotic, like a tangle of dark matter or even a cosmic string, a hypothetical defect in space-time left over from the birth of the universe. But the real shocker, the Great Attractor might not even be the final destination. Recent observations reveal something even larger lurking beyond it, the Shapley supercluster, a structure so immense it could be the true anchor of this cosmic tug of war. This discovery raises staggering questions. Are we seeing just one layer of a hidden cosmic hierarchy? Could there be other, even grander structures shaping the universe's expansion in ways we don't yet understand? The Great Attractor isn't just a mystery, it's a doorway into a deeper truth about how the cosmos organizes itself on scales we're only beginning to comprehend. Just when we thought space couldn't get any more mind-bending, the Hercules-Corona Borealis Great Wall enters the scene, a cosmic titan so enormous it stretches the very definition of what we thought was possible. Imagine a structure spanning 10 billion light-years, a filament of galaxies so vast it could contain tens of thousands of Milky Ways strung together like beads on an invisible thread. This isn't just big, it's a fundamental challenge to our understanding of the universe's structure. Here's what makes this discovery so staggering. according to our best models of cosmology, there's supposed to be a limit to how large matter can clump together. The universe, in its early moments, was thought to be too smooth and evenly distributed to allow for structures of this scale to form. Yet the Hercules-Corona Borealis Great Wall defies that logic, existing as a colossal anomaly that forces scientists to question whether we've underestimated the cosmos' ability to organize itself. Some researchers suggest this wall might be a remnant of the universe's infancy, a fossilized imprint of ancient density fluctuations that somehow survived billions of years of cosmic expansion. Others wonder if it's pointing us toward gaps in our understanding of dark energy or gravity itself. Could there be unknown forces sculpting the universe on scales we're only now beginning to map? What's even more humbling is realizing this might not be the only one. As our telescopes peer deeper into space, we're finding hints of other megastructures lurking in the darkness, each one pushing the boundaries of what we thought was cosmologically possible. The Hercules-Corona Borealis Great Wall isn't just a curiosity, it's a cosmic wake-up call, reminding us that the universe still holds mysteries far beyond our current imagination. Now we come to one of the most energetic mysteries lurking right in our own galactic backyard, the Fermi Bubbles. Picture two colossal orbs of superheated gas, each stretching 25,000 light-years from the Milky Way center, towering above and below our galaxy's disk like ghostly hourglasses. These aren't just any cosmic formations, they're pumping out enough gamma radiation to light up telescopes across the universe, yet they remained hidden from human detection until just over a decade ago. What makes these bubbles so baffling isn't just their size, it's the sheer violence they imply. The energy required to inflate structures this massive could only come from something cataclysmic, like a supermassive black hole feasting on matter in an ancient frenzy. Imagine Sagittarius, a star, the black hole at our galaxy's heart, erupting in an outburst so powerful it launched jets of plasma at near light speed, carving these bubbles into space like cosmic graffiti. But here's the twist: we've never witnessed our black hole behaving this violently in recorded history, which means if this theory holds, we're seeing echoes of a galactic tantrum from millions of years ago. Yet some scientists propose an even wilder explanation: dark matter annihilation. If invisible dark matter particles collide and destroy each other near the galactic center, they could theoretically release the exact kind of energy we see glowing within these bubbles. This idea turns the Fermi bubbles into potential evidence for one of physics' greatest unsolved puzzles, the true nature of dark matter itself, but the plot thickens further. Recent observations reveal the bubbles aren't just smooth shells, they're threaded with bizarre substructures, including filament-like tendrils and knots of even more intense radiation. Some researchers speculate these could be scars from multiple outbursts, like a black hole sneezing repeatedly over cosmic time. Others wonder if we're seeing the aftermath of an entire star cluster plunging into the black hole at once, detonating like a celestial bomb. One thing's certain: the Fermi bubbles are forcing us to rewrite the biography of our own galaxy. They paint a picture of the Milky Way not as a tranquil spiral, but as a place of episodic violence, where the quiet black hole we see today was once a raging monster. And if such eruptions happen periodically, could another one be brewing even now? The more we study these gamma-ray ghosts, the more they remind us that even our home galaxy holds secrets wilder than we ever imagined. But if you think the universe's mysteries stop at massive structures, prepare to have your expectations turned inside out, because next, we encounter the exact opposite: a cosmic desert so vast and empty it defies logic. The Boötes Void isn't just a quiet corner of space, it's a staggering spherical abyss stretching 330 million light-years across, where galaxies are almost entirely absent. Astronomers call it the Great Nothing, and that name doesn't even begin to capture how unsettling this place truly is. Picture dropping the Milky Way into this void. Our galaxy would be one of just 60 lonely islands in a darkness the size of 10,000 Milky Ways laid end to end. To put that in perspective, a region this size should contain at least 2,000 galaxies based on our standard models of cosmic structure. Instead, it's as if someone took an eraser to this patch of the universe, scrubbing away nearly everything. The few galaxies that do exist here aren't just rare, they're oddly isolated, drifting like ships in an endless black sea with no neighbors in sight. What could possibly create such a barren expanse? One theory points to dark energy, the mysterious force accelerating the universe's expansion. Could this void be a magnified example of dark energy's handiwork, stretching space so rapidly that galaxies were ripped apart or pushed beyond visibility? Others wonder if it's a relic of the universe's birth, a frozen bubble from cosmic inflation, where quantum fluctuations left a region so underdense that matter never fully condensed. But the most spine-tingling possibility, the Boötes Void might not be alone. Smaller mini-voids have been spotted elsewhere, hinting that our universe could resemble cosmic Swiss cheese on scales we're only beginning to map. If true, it would mean the cosmos isn't just lumpy with clusters and walls, it's also pockmarked with these unsettling gaps, rewriting the textbook on how matter distributes itself across the heavens. Here's where it gets even stranger. Some researchers speculate these voids might be hiding something even more exotic. Could they contain concentrations of dark matter so dense they repel normal matter, or portals to other dimensions, as fringe theories suggest? While that remains speculative, one thing is certain: the Boötes Void forces us to confront how little we truly grasp about the universe's architecture. It's not just an absence, it's a screaming anomaly that proves emptiness can be just as puzzling as the most crowded cosmic structures. Now we turn our gaze from the vast emptiness of cosmic voids to something far closer, yet just as bewildering. High above Saturn's North Pole, a storm rages unlike anything else in our solar system. This isn't just another swirling tempest, it's a perfect hexagon, a six-sided geometric wonder so precise it looks like it was etched into the planet's atmosphere by some cosmic architect. Stretching wider than two Earths stacked side by side, this atmospheric anomaly has churned relentlessly for at least 4 decades, possibly much longer, defying every expectation of how planetary weather should behave. What makes Saturn's hexagon so extraordinary isn't just its shape, it's the fact that such geometric perfection exists in the chaotic realm of fluid dynamics. Here on Earth, storms spin in rough circles or ovals, driven by the Coriolis effect. But Saturn's hexagon maintains razor-sharp angles even as hurricane force winds whip around its edges at over 300 miles per hour. Imagine drawing a hexagon in smoke while a fan blows. That's the level of impossibility we're dealing with on a planetary scale. Scientists have scrambled to explain this through laboratory experiments and supercomputer simulations. Some theories suggest the hexagon might be a standing wave pattern, where atmospheric currents interact with Saturn's rotation to create stable geometric shapes. Others propose it's a colossal version of what happens when you stir fluids at just the right speed, creating stable vortices at the corners that lock in the hexagonal form. But here's the catch: no simulation has perfectly replicated both the hexagon's sharp edges and its mind-boggling longevity. The mystery deepens when we consider this storm's eerie stability. While Earth's hurricanes dissipate in days or weeks, Saturn's hexagon has outlasted multiple generations of scientists. Some researchers speculate that without solid continents to disrupt airflow, as on Earth, Saturn's atmosphere can maintain these perfect patterns indefinitely. Others wonder if the hexagon's roots extend deep into the planet's interior, possibly tied to Saturn's strange magnetic field or internal heat dynamics. Perhaps most tantalizing is what this tells us about planetary science as a whole. If we can't fully explain weather patterns on a planet in our own solar system, how can we hope to understand the atmospheric dynamics of distant exoplanets? The hexagon stands as a humbling reminder that even familiar cosmic neighbors still harbor profound secrets. Every time the Cassini spacecraft sent back new images of this swirling geometric marvel, it wasn't just showing us a pretty picture, it was revealing a fundamental gap in our understanding of how fluid dynamics operate across the universe. And here's where it gets truly fascinating. The hexagon isn't just a static shape. Recent observations show its colors change with Saturn's seasons, shifting from golden hues to deep blue as sunlight angles vary over the planet's 29-year orbit. Some layers of the hexagon even rotate at different speeds, creating a mesmerizing, multidimensional weather system that operates like nothing else we've ever seen. This isn't just a scientific curiosity, it's a natural laboratory challenging us to rethink everything we know about atmospheric physics on a cosmic scale. Saturn's hexagon represents more than just a pretty puzzle. It's a gateway to understanding how order emerges from chaos across the universe. From the quantum realm to galactic structures, nature often arranges itself in geometric patterns we're only beginning to recognize. The hexagon whispers that there might be fundamental principles of organization woven into the fabric of reality itself, rules we've yet to fully decipher. As we continue studying this atmospheric enigma, we're not just learning about Saturn, we're glimpsing the universal language of storms, written in geometry and wind. Just when we thought galaxies couldn't surprise us further, the universe unveils Hoag's object, a celestial oddity so visually stunning it looks like someone dropped a cosmic bullseye into deep space. At first glance, you'd swear this was some elaborate artist's rendering, a golden sphere of ancient stars floating perfectly centered inside a brilliant blue ring, with nothing but inky blackness separating them. But this isn't conceptual art, it's a real galaxy located 600 million light-years away, challenging everything we thought we knew about galactic formation. What makes Hoag's object so extraordinary is its impossible symmetry. Most ring galaxies, like the famous Cartwheel Galaxy, form through violent collisions where one galaxy punches through another, sending shockwaves that compress gas into a star-forming ring. Yet Hoag's object shows no signs of such trauma, no distorted tails of debris, no secondary galactic core hiding in the shadows. Its central bulge and outer ring exist in perfect isolation, like a diamond suspended inside a hula hoop, with a gap so clean it defies conventional explanations. Astronomers have proposed wild theories to account for this precision. One possibility suggests a density wave rippled through the galaxy billions of years ago, triggering star formation in that exact circular pattern while leaving the center untouched. Others speculate this might be the aftermath of an extreme bar instability where a galaxy's central bar of stars somehow morphed into both the core and ring we see today. But the most tantalizing hypothesis, Hoag's object could be a rare snapshot of galactic seeding, where an ancient accretion of gas collapsed into two distinct star-forming zones simultaneously, creating this dual structure in one flawless cosmic breath. The plot thickens when we peer deeper into that sapphire ring. Unlike the old yellow stars in the central bulge, the ring blazes with young blue stars and glowing pink nebulae, evidence of ongoing stellar birth. This presents yet another puzzle. How does star formation continue so vigorously in the ring without the usual triggers like galactic mergers or nearby companions? Some researchers suggest invisible reservoirs of cold gas might be feeding the ring from intergalactic space, while others wonder if dark matter interactions could be playing a role we don't yet understand. Even more mind-bending, Hoag's object isn't entirely alone. Zooming out reveals at least 2 other tiny ring galaxies floating nearby like cosmic ducklings, hinting that this region of space might be a breeding ground for these peculiar structures. Could there be unique environmental factors here that foster ring galaxy formation without collisions? Or are we seeing the aftermath of some bizarre galactic interaction that occurred so gently it left no other traces? What makes this discovery so thrilling isn't just its beauty, it's the realization that galaxies might evolve through pathways we've never imagined. For decades, astronomers viewed galactic collisions as the primary sculptor of ring structures. Hoag's object whispers a different story, that the universe can craft perfection through quieter, more mysterious means. It stands as a glittering challenge to our textbooks, proving that sometimes the most profound cosmic truths come wrapped in the most elegant puzzles. And perhaps the most humbling thought of all, if we'd been born in a planetary system inside Hoag's ring, our night sky would look utterly surreal. A band of young blue stars arching overhead, with the golden glow of the central bulge forever floating in the distance like a distant celestial lantern. It's a reminder that the universe isn't just stranger than we imagine, it's stranger than we can imagine, with each new discovery rewriting the rules of what we thought was possible. Of all the cosmic mysteries that have captured our imagination, few are as tantalizing or as frustrating as the WOW signal. Picture this, it's a quiet summer night in 1977 at Ohio State University's Big Ear radio telescope. A volunteer astronomer named Jerry Amon is sifting through pages of data when his eyes lock onto a string of numbers and letters so unexpected he circles them in red pen and scribbles, "Wow." In the margin, that single word would give name to one of the most enduring enigmas in astronomy, a radio burst so powerful, so peculiar, it seemed to scream, "We are here." The signal itself was unlike anything natural telescopes had ever picked up. For 72 electrifying seconds, it blazed at 1420 megahertz, a frequency silent to cosmic background noise but perfect for cutting through interstellar space. Think of it like hearing a single, perfect note played in an empty concert hall. No build-up, no fade-out, just a clear tone where none should exist. Even stranger, the signal's intensity spiked and dipped exactly as you'd expect if it came from a fixed point in the sky, matching the telescope's rotation as it scanned the constellation Sagittarius. This wasn't static or equipment glitch, it behaved like a deliberate transmission. But here's where the mystery deepens. Despite decades of searching, the signal never repeated. Not once, astronomers have combed that patch of sky with increasingly sensitive instruments, hoping for another whisper from the void. All they've found is silence. So what could have caused such a fleeting but perfect burst? One camp argues it might have been an extreme astrophysical event, like a comet's hydrogen cloud glowing at just the right frequency, or a previously unknown celestial phenomenon. Yet no natural explanation fully accounts for the signal's narrowband precision, a hallmark of artificial transmission. Then there's the other possibility, the one that sends shivers down the spine. Could this have been a momentary blip from an alien civilization? The signal's frequency aligns eerily with the water hole, a quiet band of the spectrum where hydrogen and hydroxyl molecules emit radio waves. A logical place for advanced beings to broadcast, since water is universal to life as we know it. Some researchers speculate the WOW signal might have been a targeted beacon, sweeping past Earth like a cosmic lighthouse beam, never to return. Others wonder if it was a fragment of a longer message, most of which missed our planet entirely. What makes this mystery so compelling isn't just the unanswered questions, it's what the signal represents. In a universe that's existed for 13.8 billion years, 72 seconds is less than a blink. Yet that blink forced us to confront a humbling truth. We might not be alone, and if we are listening for others, they might only speak once, the wow. Signal endures as a cosmic Rorschach test, a brief ripple in the static that lets us project our deepest hopes and fears onto the universe's blank canvas. Whether it was aliens, a freak of astrophysics, or something beyond our current understanding, one thing is certain. For those 72 seconds, the universe didn't just feel vast, it felt alive. And perhaps the most profound lesson lies in the silence that followed. The wow signal reminds us that the search for cosmic company isn't just about finding answers, it's about learning how to listen. Every time we point a radio telescope skyward, we're not just hunting for signals, we're rehearsing for the day the universe might finally say hello again. Until then, that single red wow on a decades-old printout stands as both a monument to our curiosity and a challenge. Keep listening, because the cosmos rarely shouts, it whispers. Among all the stars we've studied, none has provoked more scientific intrigue and outright bafflement than KIC 8462852, better known as Tabby Star. This unassuming flicker of light in the constellation Cygnus behaves like no other sun in the cosmos, dimming erratically by as much as 22% for days or weeks at a time before brightening again. To grasp how extraordinary this is, imagine if our own sun suddenly faded by a fifth without warning, an event so extreme it would rewrite every textbook on stellar physics overnight. What makes Tabby Star truly mind-bending is the irregularity of these dimming events. Most stars with planets exhibit predictable, periodic dips like clockwork when their worlds transit across the face. But this star's light fluctuations are chaotic with no discernible pattern. Some dips are shallow and brief, others plunge dramatically and linger. The deepest recorded dimming events blot out staggering amounts of starlight equivalent to something 50 times Jupiter's width passing in front of it. And here's the kicker: no known natural phenomenon can fully explain it. Astronomers have thrown every conceivable explanation at this mystery. Could it be a colossal swarm of comets, thousands of times more numerous than our solar systems, crumbling into dust as they spiral toward the star? That was the initial theory, but the math doesn't quite add up. The energy required to sustain such constant disintegration would be unimaginable. Others suggest an immense protoplanetary disk, warped and twisted by gravitational interactions, might be casting these erratic shadows. But observations reveal no excess infrared heat, the telltale signature of warm debris that such disks should emit. Then there's the hypothesis that made headlines worldwide: alien megastructures. Specifically, a Dyson swarm, a hypothetical array of energy-collecting satellites or habitats built by an advanced civilization to harness their star's power. While scientists caution against jumping to extraterrestrial conclusions, the sheer scale of the dimming forces us to consider possibilities beyond conventional astrophysics. After all, nature doesn't usually build in geometric precision, and some of Tabby Star's light patterns resemble what superstructures might produce as they rotate. But the plot thickens further. Historical analysis of century-old photographic plates reveals something even more startling. Tabby Star appears to have been gradually fading overall by about 1% per year for at least the past century. This long-term dimming is completely unprecedented. Stars of its type should remain stable for billions of years. Whatever's happening here isn't just irregular, it's evolving on human timescales, which makes it all the more compelling to study. Recent observations have added new wrinkles to the mystery. Spectroscopic studies show the star's light dims more at some wavelengths than others, a clue that whatever's blocking it isn't completely opaque, but perhaps porous or made up of fine particles. Some researchers now speculate we might be witnessing the aftermath of a planetary collision, where the debris field hasn't yet settled into orderly rings. Others wonder if the star itself is behaving abnormally, with unprecedented magnetic activity or plasma ejections distorting our view. What makes Tabby Star so revolutionary isn't just the mystery itself, it's how astronomers responded. When traditional explanations fell short, they crowdsourced data analysis and launched a massive Kickstarter campaign to secure telescope time, proving how modern science can adapt to cosmic puzzles. This star has become a Rosetta Stone for stellar oddities, teaching us to expect the unexpected. Every new observation peels back another layer, revealing not just an anomaly, but a cosmic lesson. The universe still holds phenomena we haven't even dreamed of yet. Perhaps most fascinating is what this means for how we study the cosmos moving forward. Tabby Star wasn't found through targeted observation. It was flagged by an algorithm sifting through Kepler Space Telescope data, proving that the next great discovery might be hiding in plain sight, waiting for us to ask the right questions. As we continue monitoring this stellar enigma, one thing becomes clear: whether the answer turns out to be comets, collisions, or something beyond our current imagination, Tabby Star has already reshaped how we approach the greatest detective story of all, the mystery of the cosmos itself. Even as we map the farthest reaches of the observable universe, there's a peculiar motion in the cosmos that shouldn't exist, a ghostly current dragging thousands of galaxy clusters in the same direction at breakneck speeds. Astronomers call it the dark flow, and it's as unsettling as it sounds. Imagine throwing confetti into the air, only to watch every piece inexplicably drift toward the same corner of the room, except here, the confetti is entire clusters of galaxies, each containing hundreds of billions of stars, all moving cohesively toward some unseen horizon at over 2 million miles per hour. What makes this discovery so revolutionary isn't just the motion itself, it's where it's pointing. These galaxy clusters aren't being pulled toward any known supercluster or cosmic void within our observable universe. Their trajectory suggests an immense gravitational anchor lurking beyond the cosmic horizon, far past the 13.8 billion light-year limit of what we can see. This raises a staggering possibility. Our universe might be feeling the gravitational whisper of something inconceivably massive from elsewhere. Theories attempting to explain the dark flow range from the profound to the mind-shattering. One camp suggests it could be evidence of a neighboring universe in the multiverse, an entirely separate space-time bubble exerting gravitational influence on ours. Picture two soap bubbles floating close together. Even if they never touch, their nearness could create subtle distortions. If true, this would be our first potential glimpse of physics operating beyond our cosmic walls. Others propose even wilder explanations, like exotic defects in the fabric of spacetime left over from the Big Bang cosmic knots, so dense they warp the motion of matter across billions of light years. There's also the controversial idea that our understanding of gravity itself might be incomplete on the largest scales, requiring new physics to explain why the universe appears to be flowing like a river toward some unseen waterfall. But here's where the mystery deepens. Not all scientists agree the dark flow exists. Some argue it could be an illusion caused by incomplete data or systematic errors in measuring galaxy motions. Yet multiple independent studies, including analyses of the cosmic microwave background, keep hinting at this large-scale drift. The most compelling evidence comes from galaxy clusters so distant that the expansion of space between them should drown out any coordinated motion. and yet they still appear to move in concert. If confirmed, the implications would rewrite cosmology. The dark flow challenges the cosmological principle, the foundational idea that the universe looks roughly the same in all directions on large scales. Instead, it paints a picture of a cosmos that might be lopsided, influenced by forces from realms we can't observe. It's as if we've spent centuries studying ocean currents, only to suddenly realize the entire sea is being pulled by a moon we never knew existed. Perhaps the most humbling thought is this: whatever's causing the dark flow, it operates on scales so vast that our entire observable universe might just be a small eddy in its gravitational wake. As telescopes grow more sensitive and simulations more sophisticated, this cosmic current remains one of astronomy's most tantalizing frontiers, a silent river in the dark, beckoning us toward truths we're only beginning to fathom. The universe is an artist of infinite variety, but even among its most breathtaking creations, the red rectangle nebula stands apart, a celestial masterpiece so geometrically perfect it seems to defy the very nature of cosmic chaos. Located about 2,300 light-years away in the constellation Monoceros, this glowing structure isn't just another dying star's farewell. It's a nested series of near-perfect rectangles, like a set of cosmic Russian dolls carved from crimson light. Most planetary nebulae billow into graceful spirals or delicate shells as stars shed their outer layers, but the red rectangle's razor-sharp angles and symmetry suggest something far stranger is at work. At the heart of this enigma lies HD 44179, a binary star system where one sun has already begun its death throes. As this aging star expels its atmosphere into space, the ejected gas should form a messy, expanding cloud, yet instead, it's sculpted into these impossible right angles. The leading theory points to the binary companion's gravitational influence, which might be funneling the outflow into two opposing cones. Seen nearly edge-on from Earth, these cones could create the illusion of nested rectangles. But here's the catch: no simulation fully replicates the nebula's crisp edges or that eerie crimson glow. Then there's the mystery of its color, a deep, rich red unlike any other nebula in the sky. Spectroscopic analysis reveals the presence of complex organic molecules called polycyclic aromatic hydrocarbons, which glow when bombarded by ultraviolet light from the central stars. These carbon-rich compounds are the building blocks of life, raising fascinating questions. Could dying stars like this one be seeding the cosmos with the ingredients for biology? The red rectangle might not just be a cosmic oddity, it could be a factory for the very molecules that eventually form planets and perhaps living organisms. But the real jaw-dropper came when astronomers discovered the nebula's hidden symmetry extends far beyond what visible light shows. Infrared observations unveiled an even larger, perfectly aligned X-shaped structure spanning light years. A ghostly scaffold that suggests the rectangles are just the innermost layer of an intricate, three-dimensional puzzle. Some researchers speculate magnetic fields are shaping these outflows with impossible precision, while others wonder if we're seeing the aftermath of a stellar collision that left behind a spinning disk of debris, firing jets of material in perfectly opposed directions. What makes the red rectangle so transformative isn't just its beauty, it's the way it challenges our understanding of stellar evolution. This isn't how stars are supposed to die. The nebula's geometric perfection implies hidden forces, perhaps undiscovered physics, sculpting dying stars' last breaths with an almost mathematical precision. It whispers that even in death, cosmic objects might follow rules we've yet to decipher, turning the final act of a star's life into a grand, mysterious performance. And perhaps most poetic of all, the red rectangle is ephemeral by cosmic standards. In just a few thousand years, a blink in astronomical time, its delicate structures will dissipate into the interstellar medium, leaving no trace of its once perfect geometry. We're witnessing a fleeting moment in this star's billion-year life, a transient masterpiece that future civilizations might never see. It's a humbling reminder that the universe's greatest wonders aren't always permanent. Sometimes they're brief, brilliant flares of artistry, visible only to those lucky enough to be watching at just the right time. Hidden within the faint glow of the cosmic microwave background, the afterimage of the Big Bang itself, lies a cosmic anomaly so bizarre it might be our first glimpse of a parallel universe. Known as the cold spot, this mysterious region spans nearly 2 billion light-years and registers significantly cooler than its surroundings, as if someone took a cosmic ice cube and pressed it against the fabric of space-time. At first glance, it might seem like a minor temperature fluctuation in the universe's oldest light, but this isn't just a statistical blip, it's a full-blown cosmological crisis. The cold spot defies everything we thought we knew about the early universe. According to the standard model of cosmology, the cosmos should be broadly uniform on large scales, with minor temperature variations seeded by quantum fluctuations during inflation. The rapid expansion that occurred fractions of a second after the Big Bang. But the cold spot is too large and too cold to fit this picture. It's like finding a frozen lake in the middle of a desert, an outlier so extreme it demands an explanation beyond ordinary physics. One of the most startling theories suggests this could be the bruise from a collision with another universe. In the multiverse scenario, our cosmos might be one bubble among countless others in an eternally inflating space-time foam. If a neighboring bubble universe brushed against ours in the distant past, the energy released in that collision could have left behind this imprint, a cosmic fingerprint from beyond the edge of reality. It's a mind-bending possibility. The cold spot might be the first tangible evidence that other universes exist, separated from ours by dimensions we can't perceive. But the plot thickens. Alternative explanations range from the exotic to the unsettling. Some researchers propose the cold spot could be a supervoid, an enormous, mostly empty region of space where the lack of matter causes light to lose energy as it traverses the void, creating a cooling effect. Yet even the largest known supervoids can't fully account for the temperature drop observed here. Others speculate it might be evidence of a cosmic texture, a hypothetical defect in space-time structure left over from the universe's birth, a sort of cosmic knot that warps the fabric of reality itself. What makes this mystery so compelling is the way it forces us to question our most fundamental assumptions. If the cold spot truly is a relic of a multiverse collision, it would mean our universe isn't just one isolated entity. It's part of a vast, interconnected network of realities, each with its own laws of physics. Even if another explanation prevails, the mere existence of such an anomaly proves there are still colossal gaps in our understanding of cosmic origins. Perhaps the most humbling realization is how much we still don't know. The cosmic microwave background has been mapped with unprecedented precision, yet the cold spot remains an unsolved riddle at the heart of cosmology. Whether it's a window into the multiverse, a flaw in our theories, or something entirely unexpected, one thing is clear: the universe is still capable of shocking us with its secrets. And as long as mysteries like this linger, the story of the cosmos remains wide open, waiting for the next chapter to be written. High above our planet, hidden in the perpetual twilight of low Earth orbit, an object drifts silently, its origins debated, its purpose unknown. This is the legend of the Black Knight satellite, a story that blurs the line between space archaeology and science fiction. For decades, conspiracy theories have swirled around this alleged artificial satellite, with some claiming it's an alien probe monitoring humanity. while others insist it's a relic of lost human technology. The truth, as always, is far stranger than fiction, but no less fascinating. The myth began in the late 1950s when amateur radio operators reported picking up mysterious signals echoing from space. Newspapers at the time sensationalized the story, suggesting an unknown object might be circling Earth, possibly extraterrestrial in origin. Then, in 1960, the U.S. Navy allegedly detected a dark, unidentified satellite in polar orbit, an impossible feat for any nation at the time. The timing fueled speculation. Had something or someone been watching us long before Sputnik? But here's where science steps in. What believers call the Black Night is almost certainly a combination of misidentified phenomena. Some sightings were likely thermal blankets lost during spacewalks, their reflective surfaces glinting oddly in sunlight. Others might be fragments of old satellites or spent rocket boosters tumbling through orbit. The famous 1998 Space Shuttle Endeavour photo often cited as evidence. NASA confirmed it was a discarded thermal cover from one of their own missions. Yet the legend persists, and for good reason. The Black Night taps into something primal, our fear and fascination with the idea that we might not be alone, or that secrets hover just beyond our reach. It's a modern-day mythos, blending Cold War paranoia with humanity's timeless urge to find patterns in the unknown. The stories surrounding it reveal more about us than about any actual object in orbit, our hunger for mystery in an era when so much has been mapped and explained. What makes this cosmic tall tale so enduring isn't just the thrill of the unknown, it's the way it challenges our perception of history. If the Black Night were real, it would rewrite the timeline of space exploration, suggesting someone human or otherwise beat us to the stars. That idea lingers in our collective imagination, a ghost in the machine of scientific progress, and perhaps that's the real lesson here. Sometimes the most compelling mysteries aren't about what's out there, but why we so desperately want to believe. In an age where satellites blanket our skies, tracking everything from weather to Wi-Fi signals, the Black Night endures as a poetic counterpoint, a reminder that even in an era of unprecedented visibility, the cosmos can still hide stories we've yet to unravel. Whether space junk or something more enigmatic, its legend continues to orbit not just Earth but our imagination. At the heart of the Virgo cluster, 55 million light-years from Earth, lurks a cosmic predator, Messier 87. This colossal elliptical galaxy doesn't just harbor a supermassive black hole at its core. It wields one like a weapon, spearing the cosmos with a 5,000 light-year long jet of plasma that glows with the energy of 100 billion suns. When the Event Horizon Telescope captured humanity's first image of a black hole's shadow in 2019, it revealed M87's monstrous appetite. But the more we learn, the clearer it becomes that this celestial devourer operates by rules we barely understand. What makes this galaxy so extraordinary isn't just the black hole's staggering mass, 6.5 billion times that of our Sun, but the violence of its dining habits. Unlike the relatively quiet Sagittarius A star at our Milky Way center, M87's black hole is a messy eater, tearing apart stars and gas clouds with such force that it launches particles at near light speed into intergalactic space. Those iconic plasma jets aren't just cosmic exhaust, they're evidence of a feeding frenzy so intense it warps spacetime itself. Yet here's the puzzle: the black hole's accretion disk, the swirling buffet of superheated matter orbiting it, is oddly faint compared to the jet's brilliance. It's like watching a bonfire produce less heat than the sparks it throws off, defying every model of black hole physics. Scientists now suspect M87's black hole might be feeding in a way we've never witnessed. Instead of steadily consuming gas in a neat spiral, It could be gulping down massive, sporadic chunks, entire stars, or giant gas clouds in irregular feasts that trigger explosive outbursts. Some theories even suggest the jet is powered by the black hole's spin, acting like a cosmic slingshot that flings matter outward instead of swallowing it whole. This would explain why the jet maintains such perfect coherence over thousands of light years, never dispersing like a typical explosion but instead staying tightly focused, as if guided by invisible magnetic rails. But the real shocker came when astronomers noticed the jet isn't straight. It wobbles, precessing like a spinning top every few years, a behavior that hints at something unseen tugging on the black hole. Could there be a second, smaller black hole orbiting the primary, their dance warping the jet's path? Or is space-time itself so twisted near the event horizon that it bends the jet like light through a prism? Either scenario would rewrite our understanding of how black holes interact with their surroundings. Perhaps most unsettling is what M87 teaches us about galactic evolution. This galaxy didn't grow so massive by mere chance. It earned its cannibal nickname by devouring smaller galaxies over billions of years. The black hole's jets might even be sculpting its future meals, heating nearby gas to prevent new star formation and ensuring only the black hole gets to dine. It's a chilling reminder that the universe operates on scales of time and violence beyond human comprehension, where galaxies aren't just islands of stars, they're living, evolving predators in an endless cosmic food chain. And here's the ultimate twist. M87's black hole might be the key to understanding the universe's largest structures. Those colossal jets inject energy into intergalactic space, potentially influencing how galaxy clusters form and evolve. In a very real sense, this single black hole's eating habits could shape the fate of thousands of galaxies around it. As we continue studying this cosmic behemoth, one truth becomes undeniable. Some mysteries don't just change textbooks, they force us to rethink our place in a universe where even the hungriest monsters play a role in creation itself. Imagine a world where mountains gleam like crown jewels, where rivers of molten diamond carve valleys beneath skies choked with carbon dust. This isn't a scene from a science fiction novel, it's the likely reality of 55 Cancri, an exoplanet so rich in carbon that astronomers believe its interior could be packed with diamonds the size of continents. Located just 40 light-years away in the constellation Cancer, this blistering hellscape redefines the very meaning of precious, turning planetary science on its head in the process. Discovered in 2004, this super-Earth orbits so close to its sun-like star that a year lasts just 18 hours, and surface temperatures soar above 4,000 degrees Fahrenheit, hot enough to vaporize iron. But what makes 55 Cancri truly extraordinary isn't its scorching climate. It's the chemical quirk that sets it apart from any planet in our solar system. Spectroscopic analysis reveals an atmosphere thick with carbon monoxide and hydrogen cyanide, suggesting its crust could be composed primarily of graphite and diamond. Picture Earth's carbon content multiplied by thousands, a world where the pressure and heat bake carbon into crystalline structures on a planetary scale. The existence of such a world forces scientists to rethink how planets form. In our solar system, Earth and its rocky siblings coalesced from silicon-rich dust, creating familiar landscapes of granite and basalt. But 55 Cancri hints at an alternate cosmic recipe, one where protoplanetary disks contain far more carbon than oxygen, birthing worlds with fundamentally different geology. Some researchers speculate this could mean diamond planets are common around stars with high carbon-to-oxygen ratios, rewriting the galactic catalogue of possible worlds. Yet the real surprise came when follow-up observations revealed something even stranger. This planet might be tidally locked, with one hemisphere permanently scorched by its star while the other languishes in eternal darkness. Theoretical models suggest the day side could host oceans of molten silicon, while the night side might crystallize into sprawling diamond fields, making it a world of impossible extremes, where the very ground beneath your feet would shift from liquid fire to glittering stone as you crossed its terminator line. But here's the twist that truly boggles the mind. 55 Cancri-E's density measurements don't quite add up. Despite its carbon-rich composition, the planet is slightly less massive than pure diamond models predict. This discrepancy has led to wild theories, including the possibility of a vast subsurface ocean not of water, but of supercritical carbon dioxide, a seething, high-pressure fluid that could erupt in geysers of diamond rain. Other scientists propose the planet might be hollowed out by volcanic activity, its diamond crust underlain by caverns large enough to swallow continents. What makes this discovery so revolutionary isn't just the spectacle of a diamond planet. It's what it implies about the diversity of worlds waiting to be found. If planets can form from materials this exotic, what other unimaginable landscapes might exist? Could there be worlds of solid metallic hydrogen or mountains of frozen neon? 55 Cancri-E stands as a glittering testament to the universe's creativity, proving that even our wildest fantasies might pale next to reality's inventiveness. And perhaps most tantalizing of all, while this world is far too hostile for life as we know it, its existence expands the boundaries of what habitable might mean elsewhere. On a cooler carbon planet, could diamond-based crystals assemble into complex structures unlike anything in our biochemistry? It's a reminder that the universe doesn't play by Earth's rules, and that the rarest treasures in the cosmos might not be gems, but the revelations hidden in their starlit facets. In the vast silence between galaxies, where darkness stretches for millions of light years, astronomers recently stumbled upon something that shouldn't exist: enormous, ghostly rings glowing faintly in radio waves, each spanning hundreds of thousands of light years. They're called odd radio circles, or ORC, and they're unlike anything we've ever seen in the cosmos. Picture delicate, smoke-like halos floating in deep space, visible only to radio telescopes, with no obvious source at their hearts, no galaxies, no black holes, no remnants of stellar explosions. Just perfect, circular enigmas hanging in the void like cosmic echoes. What makes ORCs so baffling isn't just their size or their eerie symmetry, it's that they defy every known category of celestial object. When researchers first spotted them in 2020, they assumed they were glitches in the data. But as more of these rings emerged in surveys, the truth became undeniable. The universe had been hiding an entirely new class of phenomenon right under our noses. Some ORCs even appear to encircle entire galaxies like halos, though the galaxies themselves show no signs of the violent events that could produce such expansive shockwaves. The leading theory suggests these might be the aftermath of gargantuan intergalactic explosions, perhaps the death throes of supermassive black holes that erupted millions of years ago, sending out spherical shockwaves that now linger as faint radio echoes. Imagine tossing a pebble into a pond, except the pond is intergalactic space, and the ripples are so vast they could swallow our Milky Way whole. Yet even this explanation falls short, because no known explosion could create structures this large and this symmetrical without leaving behind some visible core or debris. Then there's the even wilder possibility. ORCs might be windows into entirely unknown physics. Some astronomers speculate they could be the imprint of warped space-time cosmic lenses created by invisible concentrations of dark matter bending radio waves into circular patterns. Others wonder if we're seeing the aftermath of collisions between parallel universes in a multiverse, leaving behind circular scars in the fabric of our reality. It sounds like science fiction, but when faced with something this inexplicable, even the most radical ideas deserve consideration. The most unsettling part. ORCs might be far more common than we realize. Early surveys suggest these ghostly rings could number in the thousands across the sky, previously overlooked because no one thought to look for perfect radio circles hiding in plain sight. Now that we know they exist, every new detection raises more questions than answers. Why do some ORCs appear around galaxies while others float in isolation? How can they maintain such crisp edges over cosmic timescales? And if they truly are shockwaves from ancient cataclysms, what kind of event could possibly leave such a clean, lasting imprint? What makes this discovery so thrilling isn't just the mystery itself. It's the reminder that even in an era of advanced telescopes and space probes, the universe still has the power to astonish us. ORCs challenge us to rethink what we know about energy, structure, and the hidden forces shaping the cosmos. They might be the first visible strands of a much larger cosmic web, one woven from phenomena we've yet to imagine. And as radio telescopes grow more sensitive, these faint rings could lead us to truths far stranger than we've dared to dream. Perhaps the most profound lesson lies in their name, odd radio circles. The word odd implies they don't fit our existing frameworks, and that's exactly what makes them revolutionary. In science, the anomalies, the things that don't make sense, are often the keys to unlocking the next great leap in understanding. ORCs aren't just cosmic curiosities, they're signposts pointing toward uncharted territories of physics, waiting for us to follow their faint glow into the unknown. Among the countless nebulae adorning our galaxy, few are as enigmatic or as strikingly beautiful as the Blue Ring Nebula. Discovered in 2004, this celestial oddity appears as a perfect azure halo surrounding a central star, glowing intensely in ultraviolet light invisible to the naked eye. At first glance, it might resemble a planetary nebula, the radiant shroud of a dying star. But the truth is far more extraordinary. This isn't just a stellar farewell. It's the cosmic aftermath of a violent celestial merger, a rare glimpse into what happens when two stars become one. What sets this nebula apart is its structure. Unlike the chaotic, asymmetrical clouds typically left behind by stellar explosions, the Blue Ring Nebula boasts an almost mathematically perfect ring, with two cone-shaped gas clouds extending from its poles like the wings of a cosmic hourglass. Spectroscopic analysis reveals something even more startling. The gas isn't expanding outward evenly, as you'd expect from a supernova or planetary nebula. Instead, it's racing away in two opposing jets at nearly 400,000 miles per hour, a telltale signature of an incredibly precise, incredibly violent event. The leading theory, roughly 5,000 years ago, a blink in cosmic time, this system wasn't one star but two. A sun-like star and a smaller companion likely orbited each other in a tight dance until gravity pulled them too close. As they merged, the smaller star was torn apart, its material spiraling into the larger star like water down a drain. But here's where the physics gets wild. Not all that stellar debris was absorbed. Some of it was ejected at incredible speeds, funneled into bipolar jets by the merged star's magnetic fields or spinning motion. The result, a shockwave of superheated gas sculpted into that iconic blue ring, a fossilized echo of the moment these stars became one. But the mysteries don't stop there. The central star, now a single, bloated object, behaves unlike any other known merged star. It's too hot for its age, radiating intense ultraviolet light that makes the surrounding gas fluoresce that vivid cerulean hue. Some astronomers speculate the merger might have reignited nuclear fusion in its core, effectively giving the star a second youth. Others suggest we're seeing the aftermath of a stellar vampirism event, where one star siphoned off the other's outer layers before the catastrophic collision. Perhaps most fascinating is what this tells us about stellar evolution. Binary star mergers were long theorized but rarely observed in this transitional phase. The Blue Ring Nebula offers a snapshot of the brief, turbulent period after the merger before the gas disperses and the star settles into its new identity. It's like catching a supernova in the act, but for stellar collisions. And given how many stars exist in binary systems, these events might shape far more of the cosmos than we ever realized. Yet the nebula still guards its secrets. Why does the ring appear so perfectly symmetrical when mergers are typically messy affairs? What created the razor-sharp boundary between the ultraviolet glowing gas and the surrounding space? Each new observation peels back another layer, revealing not just the story of two stars, but a masterclass in how the universe transforms chaos into fleeting, breathtaking order. And here's the most poetic twist: the Blue Ring Nebula won't last. In another few thousand years, the expanding gas will dilute into the interstellar medium, leaving behind only the merged star, a solitary witness to the violence that birthed it. We're witnessing a cosmic spectacle at just the right moment, a reminder that the universe's most profound lessons often come dressed in temporary beauty. For astronomers, it's a once-in-an-era opportunity, the chance to study stellar mergers not as theoretical models or ancient remnants, but as a living, glowing laboratory written in light and gas. Deep in the constellation Monoceros, the celestial unicorn lurks a cosmic paradox so baffling it's earned the nickname, the unicorn. This isn't some mythical creature, but a black hole so small it defies everything we thought we knew about how these gravitational monsters form. Weighing in at just 3 times the mass of our Sun, the unicorn isn't just petite by black hole standards, it's sitting smack in the middle of what astronomers call the mass gap, a theoretical no man's land where black holes supposedly can't exist. The mass gap has long been a thorn in astrophysics' side. Stellar evolution models predict that when massive stars die, they leave behind either neutron stars, incredibly dense remnants up to about 2.2 solar masses, or black holes starting around 5 solar masses. But between those 2 points, theory said there should be nothing. That's what makes the unicorn's discovery so revolutionary. By clocking in at roughly 3 solar masses, it's not just breaking the rules, it's forcing scientists to rewrite them entirely. How do you even detect something as elusive as a tiny black hole? The answer lies in its gravitational dance with a neighboring red giant star. As the two orbit each other, the black hole's pull distorts the star into a teardrop shape, an effect visible in subtle changes in the star's light. It's like watching someone invisible waltz across a dance floor by seeing how their partner sways. This method, called tidal distortion analysis, could be the key to uncovering a whole hidden population of these mini-monsters lurking unnoticed across the galaxy. What's truly mind-bending is considering how the unicorn might have formed. Some theories suggest it could be the remnant of an ultra-stripped supernova, a stellar explosion so anemic it barely qualifies, leaving behind this awkward in-between object. Others propose it might have started life as a neutron star that later gulped down enough material to tip it over the edge into black hole territory. There's even a wild possibility that we're seeing the product of 2 merged neutron stars, creating an object too heavy to be a neutron star but too light for conventional black holes. The implications ripple across astronomy. If the unicorn isn't alone, if the cosmos is teeming with similar mass gap black holes, it could explain mysteries like certain gravitational wave signals that don't quite fit existing models. These overlooked cosmic unicorns might hold clues to how matter behaves under extreme densities, potentially revealing new states of matter that blur the line between neutron stars and black holes. Perhaps most exciting is what this means for the hunt for exotic compact objects. The unicorn proves there are still uncharted categories of celestial bodies hiding in plain sight, waiting for new observational techniques to reveal them. It's a humbling reminder that the universe doesn't care about our theoretical boundaries. It will always find ways to surprise us with exceptions to every rule we try to impose. And as telescopes grow more sensitive, we might soon discover that what we called a unicorn was actually just the first specimen in a whole zoo of impossible creatures. The universe isn't just a scattering of isolated galaxies, it's a vast, interconnected tapestry woven from threads of dark matter and glowing gas, stretching across billions of light years in an intricate pattern astronomers call the cosmic web. Picture the neurons of a brain or the branching veins of a leaf, but on a scale so immense it makes even superclusters look like specks. This hidden architecture isn't just a backdrop, it's the scaffolding that shaped everything we see, guiding galaxies into clusters and leaving behind voids so empty they defy logic. What makes the cosmic web so revolutionary is how it redefines our understanding of cosmic structure. For decades, galaxies seemed like islands adrift in emptiness until astronomers noticed they weren't randomly placed at all. Instead, they're strung along invisible filaments like pearls on a necklace, with massive intersections where galaxy clusters swarm like bees around a hive. These filaments, made mostly of dark matter, act as cosmic highways, funneling gas and galaxies toward the densest nodes over billions of years. It's as if the universe itself is following an invisible blueprint, one written in gravity's silent language. The real magic lies in how we've begun to map this ghostly web. Using quasars, the brilliant beacons powered by supermassive black holes, astronomers can trace the faint glow of hydrogen gas illuminated by their light. Like turning on a flashlight in a foggy forest, these distant quasars reveal the web's tendrils in silhouette, showing where gas has pooled along dark matter's gravitational wrinkles. Supercomputer simulations add another layer, letting us watch the web form in time-lapse, from the universe's first whispers to the sprawling network we see today. But here's where the mystery deepens. The cosmic web shouldn't be this uniform. According to the standard model of cosmology, dark matter, the web's invisible skeleton should clump more unevenly, leaving patchier gaps between filaments. Yet observations show a startling coherence, as if some unknown force smoothed out the wrinkles in spacetime's fabric. Some theorists suggest this could hint at exotic dark matter properties, like particles that interact with each other beyond gravity's pull. Others wonder if dark energy, the force accelerating cosmic expansion, played a bigger role in the web's early shaping than we thought. Perhaps most mind-bending is the web's role in our own origins. The Milky Way didn't form in isolation. It grew by sipping gas from nearby filaments, a process still visible in the high-velocity clouds streaking through our galactic halo. Even now, we're part of the local sheet, a flat filamentary structure that includes Andromeda and dozens of smaller galaxies, all surfing the same dark matter current. This isn't just astrophysics, it's cosmic genealogy, tracing how the universe's largest structures fed the birth of stars, planets, and ultimately, us. And the web isn't static. Recent observations reveal filaments vibrating with energy, as galaxies moving through them create shockwaves that heat gas to millions of degrees. Some of these threads even glow faintly in X-rays, evidence of collisions between intergalactic winds. It's a reminder that the web isn't just a relic, it's a living, breathing structure still shaping galaxies today. What makes the cosmic web so humbling is how much we still can't see. dark matter's filaments remain invisible to telescopes, detectable only by their gravitational fingerprints. Future missions like ESA's Euclid aim to map this hidden geography in 3D, potentially revealing whether the web holds clues to dark matter's true nature or even undiscovered physics. One thing's certain, this isn't just the universe's skeleton. It's the loom on which reality itself is woven, thread by invisible thread. Few cosmic vistas capture the imagination like the pillars of creation, towering spires of gas and dust stretching 4 light-years tall in the heart of the Eagle Nebula. This iconic Hubble image isn't just visually stunning. It's a front-row seat to the universe's most dramatic creative act, the birth of stars. But these pillars aren't frozen monuments. They're dynamic, violent nurseries where gravity and radiation wage an endless tug of war, sculpting fleeting masterpieces that will vanish in cosmic microseconds. What makes these structures so extraordinary is their precarious beauty. Each pillar is a stellar maternity ward, with dense knots of gas collapsing under their own weight to ignite new suns. Hubble's famous visible light image reveals their ethereal silhouettes, backlit by the fierce ultraviolet glow of nearby massive stars. Yet this very light that makes them visible is also eroding them. Stellar winds carving away at the gas like a sandblaster, exposing fledgling stars still wrapped in their dusty cocoons. It's a cosmic race against time. Will these infant stars gather enough mass before their birth clouds are blown away? Infrared observations peel back the dusty veil, revealing hundreds of protostars embedded within the pillars, some ejecting supersonic jets as they suck in material from their surroundings. The largest protostars may already be triggering secondary star formation around them, their shockwaves compressing nearby gas into new seeds of stellar life. This isn't just one generation of stars being born. It's a cascading chain reaction, with each newborn potentially kickstarting the next. But the real surprise came when astronomers compared Hubble images taken nearly 20 years apart. The pillars are changing fast. Jets from newborn stars have lengthened visibly over this brief cosmic window, while delicate filaments of gas are evaporating at speeds exceeding 450,000 miles per hour. Some estimates suggest the entire structure could disintegrate within the next 100,000 years, a blink in astronomical terms. The pillars of creation aren't eternal. They're a momentary splash in the cosmic pond, freezing a single frame of an endless cycle of destruction and rebirth. What makes this discovery so humbling is realizing we're witnessing a universal process that shaped our own origins. 5 billion years ago, the Sun likely formed in a similar stellar nursery, its birth environment long since scattered by time and stellar winds. The pillars offer us a chance to study that ancient history in real time, a living laboratory for understanding how radiation, turbulence, and gravity conspire to turn chaos into stars, planets, and perhaps life itself. Yet, even as we marvel at their beauty, these pillars whisper a sobering truth. The universe creates through destruction. Their eventual demise will seed the nebula with heavy elements forged in young stars, enriching future generations of star systems. In that sense, the pillars of creation are also pillars of legacy, their fleeting existence a reminder that all cosmic wonders are temporary, but their echoes reverberate forever. Among the countless galaxies adorning the cosmos, few are as visually striking or as revealing as UGC 1021-4, better known as the Tadpole Galaxy. This stunning celestial anomaly looks less like an elegant spiral and more like a cosmic accident, with a bright, tightly wound head trailing a spectacular tail of stars stretching over 280,000 light-years, nearly 3 times the length of our Milky Way. But this isn't some artistic rendering of galactic chaos. It's a real-time demonstration of the universe's violent beauty, captured in mid-collision. What makes the Tadpole Galaxy so extraordinary isn't just its stretched-out shape, it's the story behind that dramatic tale. Roughly 100 million years ago, a smaller intruder galaxy plowed straight through the tadpole's disk like a bullet through smoke. The gravitational shockwave from this collision ripped stars, gas, and dust from the larger galaxy's outer layers, flinging them into space in a glittering arc. Unlike the messy debris fields left by most galactic smash-ups, the tadpole's tail formed with eerie elegance, a near-perfect stream of blue star clusters and glowing nebulae, as if the universe itself had flicked a paintbrush across the void. But here's where the physics gets wild. That tail isn't just debris. It's a stellar nursery on a scale we rarely see. As gas from the collision compressed along the tail's length, it triggered a fireworks display of star formation, lighting up the structure with young, blue-hot suns. These stars shouldn't exist so far from a galaxy's core, yet there they blaze proof that chaos can spark creation in the most unexpected places. Some of these newborn stars are already grouping into globular clusters, the kind usually found orbiting ancient galaxies. It's as if the collision didn't just distort the tadpole, it gave birth to an entirely new celestial ecosystem. The real revelation came when astronomers studied the galaxy's motion. The tadpole isn't just sitting still with a wounded tail, it's racing away from the collision site at over 2 million miles per hour, dragging its stellar stream behind it like a cosmic comet. This high-speed escape suggests the intruder galaxy wasn't some small satellite, but a substantial object packing serious gravitational punch. Yet despite searching, astronomers haven't found the culprit. It may have merged completely or been flung into intergalactic space, leaving behind only this glittering scar as evidence of the violence. What makes this discovery so transformative is how it challenges our view of galactic evolution. We used to think of galaxies as isolated islands, evolving slowly over eons. The tadpole shows us they're more like living organisms growing, colliding, and sometimes shedding pieces of themselves in cosmic scale events that reshape their destinies in mere millions of years. Its tail isn't just damage, it's a testament to the universe's ability to turn destruction into breathtaking new structures, and perhaps the most poetic detail. The tadpole's tail won't last. Over the next billion years, gravitational forces will pull it apart, scattering its stars into a diffuse halo around the main galaxy. Some of those orphan stars might even escape entirely, becoming intergalactic wanderers. For now, though, we're privileged to witness this fleeting masterpiece, a reminder that even the mightiest galaxies are temporary works of art in an ever-changing cosmic gallery. Among the countless particles zipping through the cosmos, none are as elusive or as revealing as the neutrino. These ghostly subatomic particles, so light they barely register as matter, can pass through entire planets without a single collision. But when astronomers detected ultra-high-energy neutrinos screaming across the universe from incomprehensibly distant blazars, they realized these phantoms weren't just cosmic background noise, they were fingerprints of the universe's most violent hidden engines. What makes these neutrinos revolutionary is where they come from. Blazars, supermassive black holes at the centers of galaxies, act like natural particle accelerators, firing jets of plasma and radiation directly toward Earth. When conditions are right, these jets can whip particles up to energies 1,000,000 times beyond what humanity's most powerful colliders can achieve. The neutrinos we detect are the smoking gun of this unimaginable violence, born from protons smashing into photons or gas with such force they shatter into these near-massless messengers. Unlike light, which can be scattered or absorbed, neutrinos travel billions of light years in pristine condition, carrying intel about their origins no other particle can preserve. The real breakthrough came when scientists matched high-energy neutrinos to specific blazars for the first time. It was like learning to read a new cosmic alphabet, one written not in light, but in the subtle flashes these particles create when they very rarely interact with matter. In Antarctica, the Ice Cube Neutrino Observatory waits patiently beneath the ice, its thousands of sensors tuned to catch the faint blue glow of a neutrino collision. When one of these ghosts from across the universe finally grazes an atom, it sends up a flare that tells us not just where it came from, but what kind of unimaginable forces launched it. But here's where the mystery deepens. Not all high-energy neutrinos trace back to blazars. Some arrive from seemingly empty patches of sky, hinting at cosmic accelerators we haven't yet identified. Could there be other sources, supernova with unprecedented energy, dark matter annihilations, or even exotic objects we've yet to theorize? The neutrino sky map is filling in piece by piece, revealing a universe far more violent and dynamic than our telescopes alone could show. What makes this discovery so transformative isn't just the new physics, it's the way neutrinos are rewriting how we explore the cosmos. Traditional astronomy relies on light, but neutrinos offer a parallel universe of information, piercing through dust, gas, and even entire galaxies that would obscure other signals. They're the ultimate cosmic spies, slipping past barriers to deliver secrets from the most hostile environments in existence: black hole jets, neutron star collisions, and who knows what else. And perhaps most thrilling is what this means for the future. Every high-energy neutrino we catch is like a breadcrumb leading back to some of the universe's most extreme phenomena. As detectors grow more sensitive, we're not just building a new kind of telescope, we're assembling an entirely new sense with which to perceive reality. The cosmos has been whispering to us in neutrinos for billions of years. We're finally learning how to listen. Deep in the cosmic dark, where galaxies cluster like fireflies, float some of the universe's most baffling structures: gigantic, glowing clouds of hydrogen gas stretching hundreds of thousands of light years across. Astronomers call them lyman-alpha blobs, and they're among the most brilliant and least understood objects in the cosmos. Picture a celestial jellyfish made not of tentacles, but of raw atomic energy, pulsing with a strange ultraviolet glow that defies easy explanation. These aren't just diffuse gas clouds, they're cosmic beacons shining with the intensity of billions of suns, yet with no obvious source powering their radiance. The mystery begins with their light. Lyman-alpha blobs emit a specific wavelength of ultraviolet radiation, the Lyman-alpha line, produced when hydrogen electrons drop to a lower energy state. Normally, this glow comes from stellar nurseries or quasars, but these blobs emit it on a scale that dwarfs entire galaxies. The largest known blob, Lab 1, spans 300,000 light-years and shines as brightly as the most massive galaxy clusters. Yet when astronomers peer into their hearts, expecting to find the usual suspects: bursting star formation or voracious black holes, they often find nothing. Just diffuse, glowing gas, as if the universe left its lights on but forgot to install the bulbs. So where does all this energy come from? One leading theory points to hidden galaxies buried within the gas swarms of young stars, pumping out ultraviolet radiation that gets scattered by the surrounding hydrogen like sunlight through fog. In this scenario, the blob acts as a colossal neon sign, amplifying and spreading light far beyond its original source. There's just one problem. Some blobs show no sign of enough embedded galaxies to explain their brilliance. It's like finding a city-sized bonfire fueled by nothing but a handful of matchsticks. That's where the wilder hypotheses kick in. Could these blobs be the aftermath of ancient quasar eruptions? their gas still glowing from shocks or residual heat long after the central black hole went quiet. Or perhaps they're cosmic batteries, charged by dark matter annihilations, the invisible stuff of the universe colliding with itself and releasing energy in ways we can't yet model. Some researchers even speculate that blobs might be cold accretion zones, where intergalactic gas funnels onto filaments of dark matter, heating up as it falls into the universe's hidden scaffolding. The plot thickens when you consider where these blobs live. They're most common in the early universe, spotted at redshifts that mean we're seeing them as they were 10 to 12 billion years ago, an era when the cosmos was smaller, denser, and buzzing with violent star formation. This timing suggests they might be linked to the birth of modern galaxy clusters. Their glow a side effect of the universe's messy adolescence. Some could even be proto-superclusters caught mid-assembly, their gas soon to condense into thousands of galaxies we'd recognize today. What makes lyman-alpha blobs so revolutionary isn't just their size or their glow, it's what they reveal about how the universe organizes itself. These vast, radiant clouds might be the missing link between the smooth soup of the early cosmos and the structured web of galaxies we see now. They force us to confront how little we understand about the interplay of gas, light, and dark matter on scales that dwarf our entire local galactic neighborhood. And perhaps most tantalizing of all, the biggest blobs might still be out there, lurking in the shadows of our observational limits. As telescopes like JWST peer deeper into the cosmic dawn, each new detection could rewrite our understanding of how the universe's largest structures and its most mysterious energies come to be. For now, these glowing enigmas stand as cosmic question marks, reminding us that even the most fundamental building blocks of reality still hold secrets waiting to be uncovered. Among the most violent events the universe can produce, nothing compares to the sheer cosmic whiplash of a supermassive black hole being hurled from its galactic throne. Picture this, a gravitational monster weighing millions of suns, stripped from the heart of its galaxy and sent careening through intergalactic space at speeds topping 4 million miles per hour, fast enough to travel from Earth to the Moon in under 15 minutes. But the real shocker, this runaway behemoth isn't traveling alone. Behind it streams a glittering contrail of newborn stars, stretching over 200,000 light-years like a cosmic jet trail. This isn't theoretical. Astronomers have caught one in the act, and its existence throws decades of galactic evolution theories into chaos. What makes this discovery so revolutionary is the physics behind the ejection. Supermassive black holes were thought to be irrevocably anchored to their galaxies, sitting at the gravitational center where their immense weight stabilizes entire galactic structures. For one to be flung outward requires forces beyond imagination, typically the recoil from merging two black holes of unequal size. When such a collision occurs, the resulting gravitational waves don't radiate evenly in all directions. Like a misaligned rocket engine, the lopsided blast can kick the merged black hole clear out of the galactic nucleus. Simulations predicted this could happen, but spotting an actual fugitive black hole mid-escape is like catching lightning in a bottle. The smoking gun lies in that stellar wake. As the black hole plows through intergalactic gas, its gravity compresses the material in its path, triggering star formation in its turbulent wake. This creates an almost poetic contradiction, an object synonymous with destruction inadvertently sparking creation, leaving a trail of young blue stars in its desperate flight. These aren't normal star-forming regions, they're linear and hyper-concentrated, like pearls strung along an invisible wire. The stars are also bizarrely metal-poor, suggesting the black hole is dredging up primordial gas untouched by previous stellar generations. The implications ripple across cosmology. If black holes can be evicted so easily, entire galaxies might lose their central anchors, disrupting their growth for billions of years. Some astronomers speculate this could explain dark galaxies, those mysteriously dim and diffuse structures lacking the bright cores typical of their size. Others wonder if these runaways could seed black holes in places they shouldn't exist, like the sparse voids between galaxy clusters. There's even the spine-tingling possibility that our own Milky Way's central black hole, Sagittarius A star, might have been such a traveler in its youth, arriving here after being ejected from some long-vanished predecessor galaxy. But the biggest mystery remains unanswered. Where is the recoiling black hole's counterpart? The merger that ejected it should have left behind a disturbed galactic core with telltale kinematic fingerprints, yet the suspected source galaxy shows no obvious damage. This absence forces astronomers to consider even wilder scenarios, like a slingshot maneuver involving 3 or more black holes in a chaotic gravitational tango. It's a reminder that for all our simulations, the universe still holds surprises that defy even the most sophisticated models. What makes this runaway black hole so transformative isn't just the spectacle. It's the realization that galactic centers might be far more dynamic than we ever imagined. Black holes aren't just passive anchors. They're potential vagabonds capable of rewriting their host galaxy's fates in an instant. And as observatories like the James Webb Space Telescope peer deeper into the cosmos, we may find these intergalactic outlaws are far more common than we dreamed, silently reshaping the universe one cataclysmic escape at a time. Galaxies should be predictable. They should follow the rules: spirals with dense cores, ellipticals with ancient stars, all bound together by the invisible glue we call dark matter. But the universe loves exceptions, and few are as baffling as ultra-diffuse galaxies, the cosmic ghosts that float through space almost weightless. These aren't just faint galaxies, they're sprawling, wispy structures as wide as the Milky Way, but with a fraction of its stars, so sparse you could fly through one and barely notice. Yet the real shock came when astronomers measured their motions and found something impossible. Entire galaxies moving as if dark matter, the very scaffold of the cosmos, had simply vanished. Take NGC 1052DF2, a galaxy so ethereal its stars drift like fireflies in a vast, empty auditorium. When researchers calculated its mass based on stellar motions, the numbers didn't add up. Without dark matter's gravitational grip, the galaxy's outer stars should have flown apart eons ago. Yet there it floats, serene and stable, mocking our understanding of how galaxies hold themselves together. It's like finding a bridge standing tall without supports, or a whirlpool spinning without water. The implications are staggering. Dark matter isn't just a minor ingredient in galactic recipes, it's supposed to be the foundation. According to standard models, galaxies form when dark matter halos collapse, pulling in gas to birth stars. Remove the dark matter, and the whole structure should crumble. Yet these ultra-diffuse galaxies exist in defiance, suggesting there's another way to build a galaxy, one we've yet to decipher. Some theories propose they're the shredded remains of larger galaxies, torn apart by tidal forces that stripped away both stars and dark matter. Others wonder if they formed in rare pockets of the early universe where dark matter was inexplicably scarce, like cosmic eddies in an otherwise uniform sea. But the plot thickens. Not all ultra-diffuse galaxies lack dark matter. Some, like Dragonfly 44, are practically made of the stuff, ghostly star fields embedded in massive dark matter halos. This split personality deepens the mystery. Why do some float free of dark matter's grasp while others are drowning in it? The answer might rewrite how we think about galaxy diversity, proving that the universe has more than one blueprint for building these cosmic islands. What makes these galaxies so revolutionary isn't just their defiance, it's what they reveal about dark matter itself. If galaxies can exist without it, does that mean dark matter isn't as universal as we thought? Or could it be that our measurements are missing something, some hidden factor that mimics dark matter's effects in unexpected ways? Each new discovery peels back another layer, showing us that even the most fundamental cosmic rules might have loopholes we've yet to uncover, and perhaps the most humbling thought. These ghostly galaxies might be far more common than we realized. Lurking in the shadows of brighter neighbors, they've gone unnoticed for decades, hiding in plain sight. Now that we know to look, they're turning up everywhere, silent, enigmatic, and utterly unlike anything our theories predicted. In their delicate, star-starved arms, they carry a message. The universe still holds surprises, and some of its greatest secrets might be written in the faintest ink imaginable. After journeying through the cosmos' strangest structures and most violent phenomena, we arrive at a mystery so fundamental it challenges our understanding of reality itself. Buried within the cosmic microwave background, the afterglow of the Big Bang, lies an anomaly so unsettling astronomers call it the axis of evil. At first glance, it sounds like something from a science fiction thriller, but this is very real. An inexplicable alignment in the universe's oldest light that suggests space itself might have a preferred direction, like a hidden arrow etched into the fabric of existence. The cosmic microwave background should be the universe's most democratic feature, a near-uniform glow left over from the Big Bang, with tiny temperature fluctuations randomly scattered like static on an old television. These fluctuations are cosmic fossils, imprints of density variations in the early universe that eventually grew into galaxies and clusters. But when scientists mapped this relic radiation with unprecedented precision, they noticed something chilling. The fluctuations aren't entirely random. Instead, they appear loosely aligned along a particular axis, as if the universe itself were subtly tilted. It's like tossing confetti into the air only to watch every piece drift toward the same corner of the room, a statistical impossibility unless some unseen force is at work. What makes this discovery so revolutionary is what it implies about the universe's symmetry. Modern cosmology rests on the assumption that the cosmos has no preferred direction, that it's isotropic, meaning it looks the same in all directions on large scales. The axis of evil threatens this foundational principle. If the universe has even a whisper of directionality, it could mean our standard model of cosmology is missing a crucial piece, perhaps evidence of exotic physics before the Big Bang, or a shadow of some larger structure beyond our observable horizon. Some theorists suggest this alignment might be a bruise from a collision with another universe during cosmic inflation, while others propose it's evidence that space-time itself has quantum-scale imperfections left over from creation. The controversy deepens when you consider alternative explanations. Could this be a fluke, a statistical mirage that will vanish with better data? After all, when you map the entire sky, some apparent patterns are bound to emerge by chance. Yet multiple independent studies, including data from the Planck satellite, keep hinting at this anomaly. The alignment isn't just visual, it shows up in polarized light and large-scale structure surveys too. Then there's the unsettling coincidence that this axis roughly aligns with our solar system's plane, a fact so improbable it makes some scientists wonder if we're seeing some bizarre observational bias, like light bending through unseen clouds of galactic dust. But if the axis of evil is real, the implications are staggering. It could mean the Big Bang wasn't the true beginning, just a phase transition in a larger multiverse. Or it might reveal that dark energy operates differently along this mysterious axis, subtly warping cosmic expansion in ways we've yet to detect. There's even a fringe hypothesis that this alignment traces back to primordial magnetic fields woven into spacetime itself, relics of an era before stars or galaxies existed. Perhaps the most humbling lesson here is how little we truly grasp about the universe's architecture. For all our telescopes and supercomputers, we're still decoding the cosmic microwave background's whispers, and some of those whispers seem to be telling us we've missed something profound. Whether the axis of evil is a flaw in our models, a shadow of deeper physics, or just a cosmic illusion, its very existence proves that the universe still holds cards it hasn't shown us. And that's the real takeaway. In the grand game of cosmology, the cosmos might be playing by rules we're only beginning to suspect. From gravitational anomalies to geometric wonders, these 25 celestial structures have taken us on a journey through the universe's most baffling corners, each one defying expectations and rewriting cosmic rulebooks along the way. But here's the humbling truth: for every mystery we've uncovered, a dozen more linger in the shadows. The Great Attractor tugs at galaxies with invisible hands, while Saturn's Hexagon storms rage with mathematical precision no fluid dynamics can fully explain. The wow signal whispers across light years, a single, fleeting hello that refuses to repeat. These aren't just quirks of nature, they're cosmic breadcrumbs leading us toward truths we've yet to imagine. What makes these discoveries so transformative isn't just their strangeness, it's how they expose the limits of our understanding. The universe doesn't play by human rules. It crafts diamond planets where mountains gleam like jewels, spins galaxies without dark matter, and carves perfect radio circles into the void for reasons we can't yet fathom. Every time we think we've pieced together the puzzle, the cosmos reveals another edge piece missing. And that's the real beauty of exploration. The more we learn, the more we realize how much remains hidden. Yet this isn't a story of defeat, it's an invitation. With each passing year, our tools grow sharper. The James Webb Space Telescope peers deeper into cosmic dawn than ever before. Gravitational wave detectors listen for spacetime's faintest ripples. Citizen scientists scour data for anomalies even algorithms miss. The next groundbreaking discovery might come from a backyard astronomer's telescope, a graduate student's midnight calculations, or a telescope not yet built. So as we close this chapter, remember, the universe isn't just stranger than we imagine, it's stranger than we can imagine. Those shimmering points of light above us aren't just stars, they're doorways to wonders waiting to be uncovered. Hit like if this cosmic journey sparked your curiosity, subscribe to join us for the next revelation, and drop your wildest space theories in the comments. The greatest discoveries lie ahead, and the cosmos is counting on us to keep looking up. After all, the next universe-altering mystery might reveal itself tomorrow.